So, welcome back, guys. In the last class, we have discussed about cracking, right? In that cracking, you know that cracking takes place with the help of temperature and pressure. So, by the application of temperature and pressure, if the cracking takes place, it is thermal cracking. The other one is catalytic cracking. What is that? Catalytic cracking. What is that catalytic cracking? By the application of catalyst with the help of temperature and pressure, if we are able to do the cracking, it is catalytic cracking. It is catalytic cracking. This catalytic cracking, we are going to study two types of catalytic crackings. One is fixed bed catalytic cracking. What is this? Fixed bed catalytic cracking. Fixed bed. Here the catalyst will be retained and fixed in the catalytic chamber for long time. Getting me? Once after the completion of catalytic cracking, this process, this catalyst will be deactivated. Why deactivates? We'll discuss in the we'll move on the topic. Let us discuss about why the catalyst will become deactivated. But in this fixed bed catalytic cracking, the catalyst is fixed in a catalyst chamber. To reactivate that catalyst, we have to stop the process and pick out the catalyst, and we have to regenerate it. So here the catalyst is fixed. That's why it is called fixed bed catalytic cracking. So let us see how this works. So in this, note down, there are 1, 2, 3, 4, 5, 6 columns. How many columns are there? 6. 1, 2, 3, 4, 5, 6. All the 6 columns are interconnected with each other. Right? All the 6 important parts of the fixed bed catalytic chamber is interconnected with each other through a inner tube. So the first chamber is nothing but heavy oil feeder, through which the heavy oil will be feed into the chamber. Why we are taking heavy oil? Because heavy oil contains 30 carbons. If we are able to convert the 30 carbons into 6 C5s, for example, then we will get the 6 multiply amounts of gasoline here. Okay, into 6 number of gasolines we will get here. Okay, so first to take heavy oil. Heavy oil can be feed in this chamber. Okay, yeah. Next one is catalyst chamber. This catalyst chamber have some beds placed horizontally on the two sides where the catalyst will be placed. What is the catalyst? It is a mixture of clay plus zirconium oxide. So catalyst is containing in this chamber. That's why we called it as catalyst chamber. This catalyst chamber at the bottom, it contains a heater. What is the use of heater? Heater produces heat. Okay, what is the use of heat? Okay, generally the reaction rate will be increased with the help of temperature. In this case, in cutting down the longer chain hydrocarbon into smaller chain, it is very difficult to move on with a catalyst alone. We are unable to process, we are unable to proceed the cracking alone with catalyst. If the catalyst is applied onto the longer chain hydrocarbon with the help of temperature, then the reaction takes place effectively. The reaction takes place effectively. Catalyst also break down the longer chain into smaller chains. Temperature also break down the longer chain into smaller chains. So the combination of temperature plus catalyst will increase the efficiency of cracking process, right? So that's why we use heater here. Okay, next one is called fractionation column. This is fractionating column. This one is cooler. This is cooler. This is gasoline collection chamber. Gasoline collection chamber, where cooler gives gasoline, right? That will be collected here. Okay, this contains gasoline along with some dissolved gases. The other one is fractionation column again. The other one is fractionation column. So this contains 6 chambers. One is heavy oil feeder. The other one is catalyst chamber. Next one is fractionating column. Next one is distillation cooler. Okay. The other one is heavy oil collector. Gasoline collector. The final one is fractionation column again. Right? Let us see the process. In this process, first take heavy oil. Why do we need to take heavy oil? Because heavy oil contains 30 number of carbons. Heavy oil contains 30 number of carbons. Okay, we need to convert that 30 number into 5 number range, C4 to C9 range, right? So take heavy oil, feed the heavy oil into this chamber. Now the heavy oil is moving. Okay, and entered into the catalyst chamber. The catalyst chamber already containing catalyst. The catalyst chamber already containing catalyst. Actually, when the heavy oil enters into this, by the application of temperature, that is around 400 to 500 degrees Celsius. That is around 400 to 500 degrees Celsius temperature. At the level of temperature, the heavy oil become into vapors. What is that? The heavy oil become into vapors, and the bonds in between carbon to carbon become loose become weak due to the application of heat. Okay, and also the reaction will be fast at vapor phase, gaseous phase, right? So we have converted that heavy oil into vapor state. Now the formed vapors are circulating in the catalyst chamber, and they will get absorbed on the surface of the catalyst. When they will get absorbed on the surface of the catalyst, then catalyzation will take place. That means catalyst will start working. What it will do? Then the catalyst will break down that heavy oil vapors into smaller chain hydrocarbons. Now, after some time, the heavy oil vapors converted into cracked vapors. What is that? Cracked vapors. I will write it down here. CRACKED, cracked vapors. The heavy oil vapors, after reacting with catalyst, converted into cracked vapors. Now the cracked vapors are moving into fractionating column. When the cracked vapors enters into fractionating column, Okay, the cracked vapors will fractionate. The cracked vapor will convert into different fractions. So how they will convert into different fractions? The working principle of fractionating column is to divide that vaporized heavy oil into smaller fractions. The smaller fractions contains gasoline, uncondensed gases, naphtha, so many fractions will be there. So the working principle of fractionating column is to convert the formed cracked vapors. Excuse me. To convert the formed cracked vapors into different fractions. So once the cracked vapors entered into fractionating column, they will become into different fractions by depending upon what? By depending upon their boiling points. What is that? By depending upon their boiling points. Now the formed fractions in the fractionating column enters into Kohler. Why we are passing it through Kohler? Because the formed vapors having high temperature. Okay, when we are passing it through Kohler, condensation will take place and the vapors will become into liquid. And the vapors will become into liquid according with their boiling points. Okay, yeah. Now if you see, after passing it through Kohler, the converted gasoline will be then converted into liquid. Also the gasoline contains some dissolved gases, uncondensed gases. Even we are passing it through Kohler, some vapors will remain as vapors. They are called uncondensed gases. Okay, so in this chamber we will collect the gasoline along with some dissolved gases. For the best performance of gasoline, it should not contain any other gaseous molecules. So there is a need of refinement. What is that? There is a need of refinement. In the process of refinement, again the obtained gasoline along with some dissolved gases will pass through the fractionating column. When we pass it through its fractionating column, gasoline will come alone by passing out uncondensed gases into outside. So here we have collected gasoline as a product. Gasoline as a product. What is the raw material? Heavy oil is the raw material. So in this process what we have learned is heavy oil converted into gasoline. Heavy oil converted into gasoline through the following mechanism. Once again I will explain. It contains 6 chambers. The first chamber is heavy oil feeder. Second one is catalytic chamber, catalyst chamber. Third one is fractional distillation column. The fourth one is Kohler or condenser. The fifth one is reservoir gasoline collection chamber. The sixth one is again fractionating column. First, enter heavy oil. Okay, feed heavy oil. The heavy oil is moving through this column, this tube, and will enters into the catalyst chamber. Okay, initially there 400 to 500 degrees Celsius temperature is applied. 400 to 500 degrees Celsius temperature is applied. At the level of temperature, the heavy oil will become into vapors. Okay, now the hot conditioned vapors are moving through the chamber and will be in contact with the catalyst. What is the catalyst? Here the catalyst is zirconium oxide mixed with clay. Okay, after some time, okay, the hot conditioned heavy oil reacting with this catalyst, Okay, at the level of 400 degrees Celsius temperature, the hot heavy oil vapors will then convert into cracked vapors. What is that? The hot heavy oil will convert it into cracked vapors, means breakdown vapors. Now the hot conditioned vapors are then moved through this external tube and enter into fractional distillation column. Okay, where when they enter into fractional distillation column, the cracked vapors will become into fractions, different fractions. The different fractions are then moving towards cooler. Okay, some heavy vapors will get settled down here. Okay, the gasoline containing vapors will move through the cooler. When it is passing through cooler, where cold water is placed there, okay, then the hot conditioned gasoline vapor along with some dissolved gaseous molecules will become into liquid. The gasoline liquid will be collected here. This gasoline liquid also contains some dissolved gaseous molecules, right? But we need to remove these dissolved gaseous molecules to get pure gasoline. Then pass the gasoline containing dissolved gaseous molecules again through the fractional distillation chamber. Now this fractional distillation chamber will give us pure gasoline, okay, and will leave and will throw out the uncondensed gaseous molecules to out. This is all about the working of fixed bed catalytic chamber. Okay, so this process will continue, but after some time, after some cycles, okay, when you feed heavy oil, you will not get gasoline. You are checking for the reason why. Because there the catalyst is not working properly. Why the catalyst is not working properly? That is the important question. Here the catalyst is not working properly because when 400 degrees Celsius temperature is applied onto the heavy oil will become into vapors, hot conditioned vapors. The hot conditioned vapors are moving through the chamber. That hot conditioned vapors contains some black soot particles, carbon particles. Cracked vapors along with some carbon particles, black soot particles. The black soot particles will get deposited on the surfaces of the catalyst. This process will be continuous. Okay, after few cycles, the catalyst completely covered with black soot particles. Completely covered with black soot particles. Okay, this results inactivation of the catalyst. Due to the inactive catalyst, further cracking will not take place. That's why when we feed heavy oil, again we will get heavy oil only, or not pure gasoline. Due to what? Inactive catalyst. Then how to activate the catalyst, sir? Okay, we have to stop the process. We have to stop the process. Take out the catalyst. Scrap on the surface of the catalyst. Scrap the black soot particles deposited on the surface of the catalyst. Right? The process of scrapping of black soot particles deposited on the surface of the catalyst is nothing but regeneration of catalyst. Means we have to regenerate the catalyst here. Okay, to regenerate the catalyst, we have to shut down the total equipment. Okay, so to perform regeneration step, we need to shut down the process. Why? Because here the catalyst is fixed one. That's why we called it as fixed bed catalytic cracking. Fixed bed catalytic cracking. But there is a small inconvenience. After each and every step, to regenerate the catalyst, we need to shut down the equipment and then taking out this catalyst, okay, and then reactivating that catalyst or regenerating that catalyst. It is a long process. Okay, just imagine if we are able to regenerate the catalyst automatically without shutting down the machine in a cyclic process. So deactivation takes place and reactivation taking place, inbuilt reactivation without shutting down the equipment. Okay, it will be more convenient to us. Okay, that is the next technique what we are going to discuss, is nothing but moving bed catalytic cracking. What is that? Moving bed catalytic cracking. Kindly note down.